Hey guys, welcome to this session by Intellipaat. In this session, we're going to look into the interview questions for NLP or Natural Language Processing. So natural language processing is basically the computer science of processing natural language data. So in this session, we'll be looking into three categories of NLP interview questions from basic, intermediate to advanced questions. And before moving on with this session, please subscribe to our channel so that you don't miss our upcoming videos, and also leave a like to this video or any video you watched and enjoyed from our channel. So now without any further delays, let's begin with this session.
Now let us begin with NLP interview questions and answers. So the first question is, what do you understand by natural language processing? So natural language processing is a field of computer science that deals with communication between computer systems and humans. So NLP is revolutionizing the user experience of various technologies. NLP is implemented in various areas to provide voice automation, text analysis, better customer service, and many more. Also, it is a technique used in artificial intelligence and machine learning, and it is used to create automated software that helps understand human spoken languages to extract useful information from the data it gets in the form of audio. And techniques in NLP allow computer systems to process and interpret data in the form of natural languages. Now, let us move on to the next question, which is, what are stop words? So stop words are said to be useless data for a search engine, and words such as articles, prepositions, etc. are considered as stop words. So there are stop words such as was, where, is, am, and how, why, and many more. So natural language processing, we eliminate the stop words to understand and analyze the meaning of a sentence. So the removal of stop words is one of the most important tasks for search engines, and engineers design the algorithms of search engines in such a way that they ignore the use of stop words. This helps show the relevant search result for a query. Further, let us move on to the next question, which is, list any two real-life applications of natural language processing. So the first one is Google Translate and the second one is chatbot. So talking about Google Translate, it is one of the most famous application of natural language processing. It actually helps convert written or spoken sentences into any language. Also, we can find the correct pronunciation and meaning of a word by using Google Translate. So it uses advanced techniques of natural language processing to achieve success in translating sentences into various language. So you can see over here in the image how French sentence is converted into English using Google Translate. So basically, what is the use of Google Translate? So Google Translate can actually translate multiple forms of text as well as media, which includes text, speech, and text within still or moving images also. Specifically, its function includes written words translation, and where a function that translates written words or text to a foreign language. So it can be called as a free multi-language neural machine translation that is developed by Google to translate text as well as the entire websites from one language into another. And also its accuracy, which has been criticized over time and over several occasions, has been measured to vary greatly across languages. So the application of this neural network, or you can say the natural language processing, which is Google Translate, so it can translate up to 103 languages in a number of ways, and you can just type words and sentences, speak them to the device by tapping the microphone, or even use your finger to handwrite. Now the next application is chatbot. So to provide a better customer service, companies have started using chatbots for 24/7 service, and chatbots helps resolve the basic queries of a customer. And if a chatbot is not able to resolve any query, then it forward it to the support team while still engaging the customer. So it helps make customer feel that the customer support team is quickly attending them. With the help of chatbots, companies have become capable of building cordial relations with customers, and it is only possible with the help of natural language processing. Now let us move on to the next question, which is, what is TF-IDF? So the term TF-IDF, or term frequency inverse document frequency, indicates the importance of a word in a set, and it actually helps in information retrieval with numerical statistics. For a specific document, TF-IDF shows a frequency that helps to identify the keywords in a document. Also, the major use of TF-IDF in NLP is the extraction of useful information from the crucial documents by statistical data. and it is ideally used to classify and summarize the text in the documents and filter out stop words. So TF actually helps to calculate the ratio of the frequency of a term in a document and the total number of terms, whereas IDF denotes the importance of the term in a document. So here is the formula for calculating TF-IDF. So first we have to calculate TF for a word. So it is equal to frequency of word, that is W, in a document divided by the total number of terms in the document. And for calculating IDF, the formula is log E times the total number of documents divided by the number of documents having the term W. So when TF-IDF is high, the frequency of the term is less, and vice versa. So Google uses TF-IDF to decide the index of search results according to the relevancy of pages, and the design of the TF-IDF algorithm helps optimize the search results in Google, and it helps quality content rank up in the search results. So this was about TF-IDF. Now let us move on to the next question, which is what is syntactic analysis? Now syntactic analysis is a technique of analyzing sentences to extract meaning from it. So using syntactic analysis, a machine can analyze and understand the order of words arranged in a sentence, and NLP employs grammar rules of a language that helps in the syntactic analysis of the combination and order of words in the document. So there are various techniques used for syntactic analysis, and that are as follows. So the first one is parsing. So it helps in deciding the structure of a sentence or text in the document, and it helps analyze the words in the text based on the grammar of the language. Now coming to word segmentation, that is the next technique. So the segmentation of words segregates the text into small significant units. Then the next technique is morphological segmentation. So the purpose of morphological segmentation is to break words into their base form. Then stemming, so it is the process of removing the suffix from a word to obtain its root word. Then comes lemmatization, that helps combine the words using suffixes without altering the meaning of the word. So this was about the syntactic analysis. Now let us move on to the next question. What is semantic analysis? So semantic analysis helps make a machine understand the meaning of a text, and it uses various algorithms for the interpretation of words in sentences. It also helps understand the structure of a sentence. So there are certain techniques used for semantic analysis, and these are shown in the diagram. So first one is named entity recognition. Second one is word sense disambiguation. After that, natural language generation. So starting with the first one, the named entity recognition. This is the process of information retrieval that helps identify entities such as name of a person, organization, place, time, emotion, and etc. Then coming to word sense disambiguation, it helps identify the sense of a word used in different sentences. Then in natural language generation, it is a process used by the software to convert the structured data into human spoken languages. By using NLG, organizations can automate content for custom reports. So this is about the semantic analysis. Now let us move on to the next question, which is what is NLTK? So NLTK is a Python library which stands for Natural Language Toolkit, and we use NLTK to process data in human spoken languages, and NLTK allows us to apply techniques such as parsing, tokenization, lemmatization, stemming, and more to understand natural languages. So it helps in categorizing text, parsing linguistic structure, and analyzing documents, and many more. So here are few of the libraries of NLTK package that we often use in NLP, and these are sequential back-off tagger, default tagger, unigram tagger, tree bank, wordnet, frick, dist, patterns, regex speed tagger, back-off tagger, unigram tagger, bigram tagger, and trigram tagger. Now this is about the NLTK package. Now let us move on to the next question, which is how to tokenize a sentence using the NLTK package. So tokenization is a process used in NLP to split a sentence into tokens. So sentence tokenization refers to splitting a text or paragraph into sentences. So for tokenizing, we can import sent_tokenize from the NLTK package using the line of code that you can see on your screen, that is from nltk.tokenize import sent_tokenize, and after that we can give the argument as a paragraph, that is, hi guys, welcome to Intellipaat. This is a tutorial on the NLP interview questions and answers. So after tokenizing, we'll get the output as the splitted sentences, that is, hi guys, welcome to Intellipaat, and finally this is a tutorial on NLP interview questions and answers. So here you can see the paragraph is splitted into different sentences. So this is how we tokenize a sentence using the NLTK package. Now let us move on to the next question.
Okay guys, a quick info: if you're looking for an end-to-end training in machine learning, Intellipaat provides a machine learning certification training course, and those details are available in the description box below. You can go check it out. Now let's continue with this session,
which is explain how we can do parsing. So parsing is the method to identify and understand the syntactic structure of a text. So it is done by analyzing the individual elements of the text, and the machine passes the text one word at a time, and then two at a time, further three, and so on. So when the machine passes the text one word at a time, then it is called a unigram. And when the text is parsed into two words at a time, it is a bigram. And further, the set of words is a trigram when the machine passes three words at a time. So you can see the diagram over here. It represents the unigram, bigram, and trigram. So the sentence is top 30 NLP interview questions and answers. So while parsing the text one word at a time, it gives us the output as top 30 NLP interview questions and answers separately. Each word is separate. So this is unigram. And while coming to bigram, it gives or it parses two words at a time, that is top 30 NLP, NLP interview, interview questions, questions and answers. So these are two word at a time and they are called bigrams. Then finally trigram, so it parses three words at a time. So it takes top 30 NLP interview questions, questions and answers. So it is parsed three word at a time. So they are called trigram. So to tokenize a text, we can use word tokenized from the NLTK package, and for extracting unigrams, bigrams and trigrams, we use the functions named unigrams, bigrams and trigrams by using the NLTK package. So we use it like NLTK.unigrams and we give the argument as the text, then NLTK.bigrams, then we give the text, and NLTK.trigrams and give the text, and then we'll get the output. Also for getting the text or the parsing for n-grams, we use NLTK.ngrams and we give the text with the argument n, which help us to tell the machine that we have to parse the text in for this many number of tokens. So this is about how can we do parsing. Now let us move on to the next question, which is explain stemming with the help of an example. So in natural language processing, stemming is method to extract the root word by removing suffixes and prefixes from a word. For example, we can reduce stemming word to stem by removing m and ing. So we use various algorithms for implementing stemming, and one of them is Porter stemmer. So this is a basic code you can see on your screen to implement stemming. So from NLTK.stem, we have to import Porter stemmer. Then we have to create an object for Porter stemmer using the PST equal to Porter stemmer. Then after that, for stemming the word, we use PST, that is the object for Porter stemmer dot stem, and then we give the argument in the form of a word that we need to stem out. Then here we have given PST.stem for running, PST.stem for cookies, and PST.stem for flying, and then we get the output as run, cookie and fly. So this is how we do stemming. Now let us move on to the next question, which is explain lemmatization with the help of an example. So we use stemming and lemmatization both to extract the root words. However, stemming may not give the actual word, whereas lemmatization generates a meaningful word by extracting the root, or you can say the actual root word, from the word that you have given. So in lemmatization, rather than just removing the suffix and the prefix, the process tries to find out the root word with its proper meaning. So for example, if we have a word called bricks, so it becomes brick. Corpora becomes corpus. So we can implement lemmatization using the below code. So first we have to import certain packages from NLTK. So here is the code. From NLTK.stem, we have to import wordnet. Then from NLTK.stem, we have to import wordnet lemmatizer. Then we have to create an object for wordnet lemmatizer. So for this, we'll use this lemma for lemmatization, and we'll use this method wordnet lemmatizer. So we'll give the list as dogs, corpora and studies. So we'll implement the logic. For n in the list, where n is the number of elements. Then we have to print n plus the word that we have lemmatized. So after the implementation, or you can say the proper implementation of lemmatization, will get the result as dogs become dog, corpora become corpus, and studies become study. So this gives us the actual root word from the words that we have input in the algorithm, or we can say the logic. So lemmatization actually generates a meaningful word. Now let us move on to the next question, which is what is parts of speech tagging. So the parts of speech tagging is used to assign tags to words such as nouns, adjectives, verbs, and many more. So the software uses the POS tagging to first read the text and then differentiate the words by tagging. So the software uses algorithm for the parts of speech tagging. So POS tagging is actually one of the most essential tools in natural language processing, and it helps in making the machine understand the meaning of a sentence. So POS tagging is also essential for building lemmatizers, which are used to reduce a word to its root form. Also, POS tagging is the process, you can say, of marking up a word in a corpus to corresponding part of a speech tag based on its context and definition. So this is about parts of speech tagging. Now let us move on to the next question, which is explain named entity recognition and its benefits. So named entity recognition is an information retrieval process, and NER helps classify named entities such as monetary figures, location, things, people, time, and many more. So it allows the software to analyze and understand the meaning of the text, and it is mostly used in NLP, artificial intelligence, and machine learning. So one of the real life application of NER is chatbots used for customer support. Also, one additional information to add, the package for implementing the named entity recognition is available in Spacey package. So we have to import Spacey for implementing the named entity recognition. Now let us move on to the next question, how to check word similarity using the Spacey package. So to find out the similarity among words, we use word similarity, and we evaluate the similarity with the help of a number that lies between 0 and 1. So we use the Spacey library to implement the technique of word similarity. So here is the code. First we have to implement Spacey, then we'll use this NLP keyword where we'll load the requirements for implementing the word similarity using spacey.load, and then we have to input the word, then we have to implement the logic for I in tokens, and first we'll take I.text, then I.has vector, then vector underscore norm, and so on with token 1, token 2. So then we have to print similarity between words where we'll use this similarity function. So if we want to check the similarity between token 1 and token 2, so we'll use it as token underscore 1 dot token underscore 2 inside similarity function, and then we'll get the output. So when we'll get the similarity, or we can say the parameter or the value is between 0 and 1, so you can see it over here, 0.597265. So this shows us the extent of similarity between the words. So this is about how can you check the word similarity using the Spacey package. Now let us move on to the next question. List the components of natural language processing. So here are the major components of natural language processing, that is entity extraction, syntactic analysis, pragmatic analysis, morphological and lexical analysis. So starting with the first one, so entity extraction refers to the retrieval of information such as place, person, organization, etc. by the segmentation of a sentence. So it helps in the recognition of an entity in a text. Now coming to syntactic analysis, so syntactic analysis help draw the specific meaning of a text, and then pragmatic analysis is used to find useful information from a text. We implement pragmatic analysis technique. Then coming to morphological and lexical analysis, it helps in explaining the structure of a word by analyzing them through parsing. So these are the components of natural language processing. Now let us move on to the next question. So define the terminology in NLP. So there are various terminologies in NLP that actually helps to implement NLP for any application, and the interpretation of natural language processing depends on various factors, and there are certain terminologies to define them, and they are as follows. So there are weights and vectors, structure of the text, sentiment analysis, classification of text, machine reading. So starting with weights and vector, we use TF-IDF. So we already discussed what TF-IDF is. So just for a recap, TF-IDF, or you can say the term frequency inverse document frequency, indicates the importance of a word in a set, and it actually helps in information retrieval with numerical statistics. So talking about a specific document, TF-IDF shows a frequency that helps identify the keywords in a document. And also the major use of TF-IDF in NLP is the extraction of useful information from crucial documents by using the statistical data, and it is ideally used to classify and summarize the text in documents and filter out stop words. Also, we saw the formula for calculating TF-IDF. Then we look into the length, and we also look into the Google word vectors and the individual word vectors. Then comes structure of the text, where we use POS tagging, head of sentence, and named entity recognition.
Okay guys, a quick info: if you're looking for an end-to-end training in machine learning, Intellipaat provides a machine learning certification training course, and those details are available in the description box below. You can go check it out. Now let's continue with this session.
So just for a recap, named entity recognition is an information retrieval process, as we already discussed about it, and it helps classify named entities such as monetary figures, location, things, people, time, and many more. Also, it allows the software to analyze and understand the meaning of the text, and it is mostly used in NLP, artificial intelligence, and machine learning. And one of the real life example that we already discussed is chatbots used for customer support. Then comes sentiment analysis. So the knowledge of characteristics of the sentiment that we use for building the application. Also knowledge about entities and the common dictionary available for sentiment analysis. Then comes classification of text, where we use supervised learning algorithm, training set, validation set, test sets, features of the text, as well as LDA. Then comes machine learning, where we use removal of possible entities, joining with other entities, and DBpedia for creating the application such that the outcome, or you can say the prediction of the machine, is accurate. Now further, let us move on to the next question, which is what is latent semantic indexing, that is LSI. So the latent semantic indexing is a mathematical technique used to improve the accuracy of the information retrieval process, and the design of LSI algorithm allows machines to detect the hidden, that is called the latent, correlation between semantics, that stands for words in NLP. So to enhance the information understanding, machines generate various concepts that associate with the word of a sentence. Then the technique is used for information understanding, and it is called singular value decomposition, and it is generally used to handle static and unstructured data. Also, the matrix obtained for singular value decomposition contains rows of words and the columns for documents. So this method best suits to identify the components and group them according to their types. So the main principle behind using LSI in natural language processing is that words carry a similar meaning when used in a similar context. So the objective of using LSI is used to find the similar context. So the computational LSI models are slow while using in natural language processing in comparison to other models for identifying the similar context meaning sentences. However, they are good at contextual awareness that helps improve the analysis and understanding of a text or a document. So this is about LSI. Now let us move on to the next question, which is what are regular expressions? So a regular expression is used to match and tag words, and it consists of a series of characters for matching strings. Suppose if A and B are regular expressions, then the following conditions will be true for A and B. So if epsilon is a regular language, then epsilon is a regular expression for it. And if A and B are regular expressions, then A plus B is also a regular expression within the language A, B. Then comes if A and B are regular expression, then the concatenation of A and B, that is A dot B, is a regular expression. And the final one is if A is a regular expression, then A times A, that is occurrence of A multiple times, is also a regular expression. So these are the rules of regular expressions. Now let us move on to the next question, which is what is a regular grammar? So a regular grammar is used to represent a regular language, and a regular grammar comprises rules in the form of A stands for small a stands for small a dot b, and many more. So the rules help detect and analyze strings by automated computation. So regular grammar consists of 4 tuples. So there is n, that is used to represent the non-terminal set. Summation represents the set of terminals, then P stands for the set of productions, and then the S epsilon n denotes the start of a non-terminal. So this is about regular grammar. Now let us move on to the next question. Explain dependency parsing in NLP. So dependency parsing helps assign a syntactic structure to a sentence. Therefore, it is also called syntactic parsing. Also, dependency parsing is one of the critical tasks in NLP, and it allows the analysis of a sentence using parsing algorithms. So there are various types of parsing algorithms available in NLP that we use to parse a sentence. Also, by using the parse tree in dependency parsing, we can check the grammar and analyze the semantic structure of a sentence. So for implementing dependency parsing, we use the Spacey package in Python that we have, and it implements token properties to operate the dependency parse tree. So here is a diagram that shows the dependency parse tree. So the sentence over here is Jonas and Riley sells pen. So the root word is sell, and then Jonas and Anne are connected with a conjunction. Then coming to subject, so and sell are connected and it is given the subject category. Then comes Riley, so it is again a conjunction. Then object is defined by sell pens. So this is actually a dependency parsing tree that help us to understand the meaning of a sentence and make the machine understand the meaning of a sentence. So this is about dependency parsing in NLP. Now let us move on to the next question. What is the difference between NLP and NLU? So the below table shows the difference. So NLP stands for, as you already know, natural language processing, and NLU stands for natural language understanding. So starting with the first difference, NLP is used to create systems capable of establishing communication between humans and computers, whereas in NLU, it provides techniques to solve complicated problems related to machine learning understanding. Then the next difference is NLP takes care of all the techniques required for the interaction between machines and humans, whereas in NLU, it actually helps convert the unorganized input data into a structure format to allow the machine to understand the data. Then the third difference is NLP provides techniques to analyze what is actually said, and in NLU, it actually helps understand what actually the sentence is or what is meant by this sentence. Now, let us move on to the next question, which is what is the difference between NLP and CI? So again, NLP is natural language processing and CI stands for conversational interfaces. So starting with the first difference, so NLP helps analyze and identify user requests, whereas a conversational interface helps mix images, videos, audios with menus, buttons, and many more. Then coming to the next point, NLP helps understand and interpret everything about a text or a document, whereas CI provides only the necessary information to users. Now the third difference is NLP is used by chatbots for providing customer support, whereas CI helps provide better customer service by understanding user queries as well as responding to them and providing a personalized experience. So this is the major difference between NLP and conversational interfaces. Now let us move on to the next question, which is what is pragmatic analysis? Now, pragmatic analysis is an important task in NLP for interpreting knowledge that is lying outside a given document. And the aim of implementing pragmatic analysis is to focus on exploring a different aspect of the document or the text in a language. Now, this requires a comprehensive knowledge of the real world. So, the pragmatic analysis allows software applications for the critical interpretation of the real world data to know the actual meaning of the sentences and words. So, just for an example, consider this sentence, do you know what time it is? So this is a question that the machine needs to understand. So this sentence can either be asked for knowing the time or for yelling at someone to make them note the time. So this depends on the context in which we use this sentence. So that is why we use pragmatic analysis for interpreting the knowledge that is lying outside a given document and not in the range of the machine. So we need to train the machine in such a way that it can interpret this type of knowledge. Now let us move on to the next question, which is what is pragmatic ambiguity? So pragmatic ambiguity refers to the multiple descriptions of a word or a sentence, and an ambiguity arises when the meaning of the sentence is actually not clear and the words of the sentence may have different meanings. Therefore, in practical situations, it actually becomes a challenging task for a machine to understand the meaning of a sentence. So this actually leads to pragmatic ambiguity. Now, just for an example, here is the sentence given over here. So, are you feeling hungry? So the given sentence could be either a question or a formal way of offering food. So for this, we need to train the algorithm, train the machine in such a way that it can differentiate and it can interpret both the meaning and the context of the sentence. So this is pragmatic ambiguity. Now coming to the next question, what are unigrams, bigrams, trigrams and n-grams in NLP? So to understand them, let us look at an example. So here is a sentence, I am feeling hungry. So as per the given sentence, it is given over here unigram, bigram and trigram. So just for a recap, when we pass a sentence one word at a time, then it is called a unigram, and when the sentence is passed 3 words at a time, it is called a trigram. Similarly, n-grams refer to the passing of n words at a time. Now coming to the example, so in unigram, each part of the sentence you can see it over here, that is I am feeling hungry. So these are unigrams. And coming to bigrams, so I am is a single entity, then am feeling is another one consisting of 2 entities, or you can say 2 tokens. Then comes feeling hungry, so again a single entity. So this is bigram. Then coming to trigram, it has 3 entities together. I am feeling hungry. So similarly, if we take n-grams, that is after parsing 3 words at a time, if it is necessary to parse 4 words at a time, 5 words at a time, then it will be according to the similar pattern that we use in unigram, bigram and trigram. Now let us move on to the next question. What are the steps involved in solving an NLP problem? So these are the steps that actually we use for solving a real life NLP problem. So first we have to gather the text from the available data set or by web scraping. So data collection is one of the important tasks before solving any problem in the field of AI, machine learning, data science, as well as in NLP in context of as we are dealing with text. So then we have to apply stemming and lemmatization for text cleaning. Then we have to apply feature engineering techniques and then embed using word2vec. After that, we have to train the built model using neural networks or other machine learning techniques. So on top of the data set or the text that we are using, we have to use any machine learning algorithm or any neural network so that we can train the model on a particular data set, so that in future it give us the results if we input new data. Then we have to evaluate the model's performance on the basis of certain parameters that are available. Then we have to make appropriate changes in the model. So if the model's performance is low, then we have to make changes so that the model is more accurate. So we use various techniques for that. And finally, we have to deploy the model for using it in real life. So these are the steps that actually we use for solving an NLP problem. Now let us move on to the next question, which is what is parsing in context of NLP? So parsing in NLP refers to the understanding of a sentence and its grammatical structure by a machine. And parsing allows the machine to understand the meaning of a word in a sentence. Also the grouping of words, there are phrases, nouns, subjects and objects in a sentence. So parsing actually helps analyze the text or the document to extract useful insights from it. So to understand parsing, let us look at an example. So here sentence is given over here, that is Jonas ate an orange, and starting from the top, so there is category named sentence and it has 2 categories, noun phrase and verb phrase. Again, noun phrase has another subcategory named as proper noun, and Jonas is assigned to the category of proper noun. Then coming to the second category, that is verb phrase. Again, it is having 2 subcategories of verb and noun phrase. So 8 is assigned to the verb category. Now the words that are left are an and orange. So there is determiner and noun. So orange is a noun and determiner is an. So Jonas ate an orange. So this is actually the parsing in context of NLP. So this is how we actually implement NLP solutions. We actually solve NLP problems using parsing. Now let us move on to the next question. What is feature extraction in NLP? So features or characteristics of a word help in context or document analysis. Also, they help in sentiment analysis of a text. So feature extraction is one of the techniques that are used by recommendation systems and for giving reviews such as excellent, good or great for a movie, or it can be negative. So all these are recognized by a recommender system. So the recommender system actually tries to identify the features of the text that help in describing the context of a word or a sentence. And after that, it makes a group or category of the words that have some common characteristics. Now, whenever a new word arrives, the system categorizes it as per the labels of such groups. So this is how we use feature extraction, and it is used in recommendation engine used by most of the companies such as Amazon, Flipkart, Myntra and many more. Now let us move on to the next question, which is what is precision and recall? So the metrics used to test an NLP model are precision, recall and F1 score. Also, we use accuracy for evaluating the model's performance. So the ratio of prediction and the desired output gives the accuracy of the model. So precision is actually the ratio of true positive instances and the total number of positively predicted instances. So precision's formula is actually true positive divided by the sum of true positive plus the false positive. So we can also write it as true positive divided by total predictive positive. Then coming to recall, it is the ratio of true positive instances and the total actual positive instances. And the formula for calculating recall value is true positive divided by the sum of true positive and the false negative. So we can also write it as true positive divided by total actual positive. So this is about precision and recall. Now moving on to the last NLP interview question. What is F1 score in NLP? So F1 score evaluates the weighted average of recall and precision, and it considers both false negative as well as the false positive instances while evaluating the model. So F1 score is also more accountable than accuracy for an NLP model when there is an uneven distribution of class. And further, formula for calculating F1 score is 2 times the multiplication of precision and recall divided by the sum of precision and recall. So F1 score is actually one of the important parameters that we use that actually gives us a measure of model's accuracy on a particular data set. And the F score is a way of combining the precision and recall of the model. And it is also defined as the harmonic mean of model's precision and recall.
Okay guys, a quick info: if you're looking for an end-to-end training in machine learning, Intellipaat provides a machine learning certification training course, and those details are available in the description box below. You can go check it out. Okay guys, that brings us to the end of this interview question session, and I hope this session was helpful and informative for you. If you have any queries, leave a comment down below. Thank you. Meet you in another session.